Okay, continuing with our Chapter 2 stacked graph examples. Again, sorry these graphs aren't actually stacked. It would make more, it would help a little bit more if these were stacked vertically, but just, again, we can't do that. So try to envision this anyway. So we got, in this one, negative acceleration starting from rest at the origin. Okay, so let's start with acceleration again this time. All we know is that the acceleration is some negative, and I should say constant, value right there. Well, that's easy. Can you draw a graph that has a negative constant y value? Sure can. Start here and just like that. It's something negative. Now recall, as we move over, or well, when these graphs are actually stacked, we'd be moving up or down. If we move this way, the y value here, all right, y value equals the slope of this graph over here. So that means we're gonna have a negative slope like that. All right, but I can't draw that quite just yet because I don't know exactly. Oops, I messed something up here. Get rid of that. Oh, I don't want to do that. Oh, sorry, that all went away. Sorry, y value equals the slope right here. What I really need to know is, where is this graph starting? Well, thankfully it tells us that we're starting from rest at the, we're starting from rest. Okay, so we're starting here, and remember now that this graph tells us, this negative y value tells us that there is a negative slope over here. So we have to start right there and then go like that. I guess I kind of did that originally, but that's what that graph would look like. Let me make that a little bit longer. All right, just like that. Okay, and now once again the y value. I'll change colors here. Y value here equals the slope over here. Okay, because the slope of displacement over time is velocity. Okay, so what's the y value? Well, the y value keeps changing negatively. It keeps getting less and less and less and less and less and less and less over time, or I should say becoming more and more negative over time. So where do we start this graph? Well, again, thankfully it says at the origin. Okay, so we're going to start here, and if it starts if velocity starts at 0 and becomes, as I oftentimes say, negativer and negativer, all right, then that means over here the slope is going to start at 0 and become negativer and negativer and negativer and negativer like that, which basically means we're going to have a downward curve. Sorry that's so messy looking right there, but hopefully that makes sense, that the y value over here, less and less and less and less and less, or, well, greater negative, 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 means a greater and greater and greater negative slope on this one right here. All right. Positive acceleration, starting with positive velocity at the origin. All right, let's start over at the acceleration point, or acceleration graph again, all right? Some positive acceleration, check, we got that. Starting with positive velocity. Okay, we can't start right here because we're starting with some positive velocity right there. All right, and if there's a positive acceleration, what's that going to mean? It means that there's going to be the positive y value right here means there's going to be a positive slope on this one. So a positive change in velocity over time. All right, then the last one right here, position versus time, where do we start it? Well, it tells us at the origin. Okay, so it starts at 0. If it didn't tell us that, we could start it wherever. And so what's going to be happening? Well, this y value gets more and more and more and more positive, which means this slope is, oh, I can't do that actually. Why can't I do what I just did? Undo that right there. Can I start with a 0 slope? No, I can't, because I didn't start with a 0 velocity, did I? I need to start with some sort of positive velocity, some sort of positive slope, and then that slope becomes more and more and more positive, or positiver and positiver and positiver like that. So it doesn't start off completely flat. Oh no, it actually starts off, oops, I can't even erase that. I'm just going to scratch that out. All right, it starts off with a positive slope right here and then becomes more and more positive. So we have a very rapidly upwardly, I shouldn't say upwardly, but more positively moving object. And that makes sense. It's got a positive velocity. Oops, I just crossed that out. It's got a positive velocity and a positive acceleration. So it's going to be moving downrange very, very rapidly. Okay? Positive acceleration starting with negative velocity at the origin. This is going to be interesting now. Okay? So we have positive acceleration, check. Positive constant acceleration, check. Starting with negative velocity, okay, so we're starting here at the origin, or if we're starting there, well, the origin would be for the other one. And so if we have a positive, we've got a positive y value here, that means we're going to have a positive slope on this one, because that slope velocity, or that slope acceleration, is equal to the y value right here. So this is interesting. What's going to happen here? Well, if we're looking at position versus time, we're told it's starting at the origin. Okay, so we got to start there. That's good. All right. But what's happening in this velocity versus time graph? Well, it starts out with a negative velocity. At some point, there's 0 velocity, and at some point later, there's a positive velocity, right? And remember, the y values here, here, and here on this graph equal the slopes, various different slopes on this graph right here. So we're going to have, starting out, we're going to have a negative slope, and then sometime later we're going to have no slope, and at some time later we're going to have a positive slope, because we go from negative to 0 to positive. So this graph on the position versus time is going to look kind of like that. Now I don't know if it completely continues over here, but at least we get the main shape of it. It starts out negative and goes to 0, and then it starts going positive. That's what this graph tells us right here. Negative velocity, no velocity, positive velocity. You're going backwards, you're stopping, and then you're going forwards. That's what that means. Next one. Negative acceleration starting with rest at the origin. All right, we should be getting the hang of this right now. Negative acceleration. Negative constant acceleration. Good. Starting from rest. Right there, starting at 0 velocity. Okay, so we're going to have a negative slope. Like that, because remember, this y value equals this slope. Negative y value, negative slope, starting from rest at the origin. Okay, so once again, we're going to ask ourselves, what's the y value here? Well, it starts at 0 and then becomes more and more and more and more and more negative. Negativer and negativer. So this slope right here is going to start out 0, and then over time it's going to become more and more and more and more negative. So we're going to have something that looks just like that. Next one, and the last one. Negative acceleration starting with positive velocity at the origin. This is going to be kind of fun. All right? So let's start with acceleration again. That's going to be easy because that's just going to be a straight constant line. But it's going to be a straight constant negative line. All right? Negative acceleration somewhere in the negative. Okay? Starting with positive velocity. Okay, so that means on the velocity versus time graph right here, we're starting somewhere like right there. Isn't that positive velocity? Isn't that negative acceleration right there? Sure is. All right, so we're starting with positive velocity, but remember, the slope right here equals the y value right here. So if this y value is negative, then that means we're going to have a negative slope. So look what happens. We're starting positively, but we're going to have it dip below that line right there. That's going to make all the difference. So as we look at our y values here, we go from a positive y value to, what's our y value right here? 0. That's 0 velocity. And now we have negative velocity right there. All right, that will help to tell us the story of this graph over here. All right, so we're starting at the origin. Got it. Check. Starting at the origin right there. So what's going on? Well, remember, the slope here equals the y value over here. So if we've got a positive y value, that means we're going to have a positive slope. Somewhere in the middle of the graph, we have 0 y value. That means somewhere in the middle, we're going to have 0 slope. And later on in this graph here, if we've got a negative y value, then later on, we're going to have a negative slope. So you can sort of picture what's going to happen right here. It's going to start out positive, flatten out, and then come back negative. And if it kept going, it would probably keep going down like that. But this is how we do stacked graphs. We take the y value of one and make that the slope of the other one. The y value of this one and make that the slope of the other one right there. So these are all related. And it kind of just barely scratches the surface of, I'm going to use the C word, of calculus. If you can understand how this changes with respect to that and this changes with respect to that, you're actually just barely starting to understand calculus. Don't worry, we're not going to do calculus in this class, but visualizing these, especially visualizing them if they're in a vertical form or stacked form, will kind of help you understand how one of these changes with respect to the other one. So that's it. That's all of our stacked graph practice examples. And if you have any other questions, make sure you see me, and I'll make sure we can practice some more in class so you really get the hang of this. Thanks for watching. I'll see you on the next one.